Hello students, we are continuing the next question. Question number 3. Given set A equal to 1, 2, 3, 4, 5, 6. Relation R x comma y is divisible by x. So that is the condition. Now you have to find this one equivalence relation or not. For this equivalence relation, we have to check reflexive, symmetric and transitive. These three conditions are satisfied, then the given set is a equivalence relation. Otherwise, it is not an equivalence relation. So, we will check now. R. So, we are writing the subsets 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Every element is divisible by itself. Next. So, R is reflexive. So, first condition satisfied. Every element is divisible by itself, so R is reflexive. Next, second one, R equal to 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So we are writing like this. Now you have to check symmetric. For symmetric, first condition, take one subset 2, 4 belongs to R. 2, 4 belongs to R. So given 4 is divisible by 2. So first condition, y is divisible by x. Y means 4 and x means 2. So this is x, this is y. So y is divisible by x. 4 is divisible by 2. But 2 is not divisible by 4. 2 is not divisible by 4. That is 4, 2 does not belongs to R. Next, transitive. X, y belongs to R. Y is divisible by x. Y, z belongs to R. Z is divisible by y. Then z is divisible by x. So this is the condition. By using this condition, now we are checking x, z belongs to R. Now take one number 1, 3. So 1, 3 belongs to R and take another one 3, 6. Now check 1, 6. This is xy. This is xy. This is yz. Then this is xz. So 1, 6. So 1, 6. Hence it is transitive. Okay. Next, fourth question. Given set A is an integer or x, y, x minus y is a integer. First one reflexive. We are taking the elements a belongs to R. Then x minus x equal to 0. So 0 is integer. Then x, x belongs to R. Symmetric. xy belongs to R and x minus y is an integer. So y minus x is integer. So y, x belongs to R. Next, transitive. X, y belongs to R. X minus y is an integer. This is the condition. Y, z belongs to R. So y minus z is an integer. Next, second condition. Therefore, x minus y plus y minus z. So plus y and minus y cancel. So x minus z is an integer. So x minus x, z belongs to R. So transitive also satisfied. Next, question number 5. Given relation R equal to x, y, x and y work at same place. Now reflexive. We are checking reflexive condition. X, x belongs to R. So x work at same place. Hence R is reflexive. Next, symmetric. X, y belongs to R. That is x and y work at same place. Therefore, next one, y and x work at same place. X and y work at same place means y and x also working at same place. Therefore, y comma x belongs to R. Next, transitive. In transitive, x comma y belongs to R. It means x and y work at same place. Y comma z belongs to R. So, y and z work at same place. Now, x and y working same place, y and z working same place. Then x and z also working at same place. That is the last meaning. X and z work at same place. Therefore, x comma z belongs to R. So, transitive also accepted. Transitive also satisfied. Next, question number 1 completed. Next, we will go to second question. Question number 2. R equal to a comma b. The a value is always less than or equal to b square. A comma b belongs to R. So, 1 by 2 comma 1 by 2 belongs to R. 1 by 2 less than 1 by 2 whole square. So, according to this condition, we are taking a as 1 by 2, b also 1 by 2. So, this condition a equal to 1 by 2 we are writing here, and less than or equal to b square means 1 by 2 whole square. So, 1 by 2 less than 1 by 2 whole square is 1 by 4. Therefore, 1 by 2 comma 1 by 2 does not belongs to R, because 1 by 2 is greater than 1 by 4. According to condition, the a value is less than or equal to b square, less than value. But here 1 by 2 is greater than 1 by 4. So, condition fail, does not belongs to R. Next, 1 comma 2 belongs to R gives 1 less than 4, but 4 less than 1. 2 comma 1 does not belongs to R. 1 comma 2 belongs to R, so 1 is less than 4. According to this condition, a equal to 1 and b equal to 2. 2 square means 4. 1 is less than 4. 2 comma 3 belongs to R. 2 less than 9. But 1 is less than 9. Condition fail. Next, 5 comma 2.5 belongs to R. 5 less than 2.5 whole square. Therefore, 5 less than 6.25. 2.5 comma 1.9 belongs to R. 2.5 less than 1.9 whole square. So, 2.5 less than 3.6. But 5 comma 1.9 does not belongs to R. Therefore, 5 less than 1.9 whole square. So, 5 less than 3.6.